Good morning, students. We'll continue the previous class. In previous class, we were discussing about the lens. It is an optical instrument. It is also a transparent material bounded with two surfaces, of which at least one should be spherical. Those lenses mainly classified into two types as a convex lens called converging lens, and one more is concave lens called diverging lens. In previous class I said how to identify which one is convex and which one is concave lens, and even these lenses again classified into subclasses based on their appearance. They being with two surfaces, based on those two surfaces they classified into different types. How they prepared based on that. See, look on this diagram here. Firstly, here I have written as a biconvex lens. Already I said bi means two. On both sides this lens is thick at the middle, which is thick at the middle called convex. On both sides it is thick at the middle, so it is biconvex lens. Next, look on this second one. I have written plano-convex. Plano-convex. Their one side is plane. Another side is thick at the middle. Means this is convex. This side plane. So it is called as plano-convex lens. Here I have drawn that diagram. Then look on the third one. It's a biconcave lens. Biconcave. Look on this diagram. On both sides, this lens is thin at the middle, which is thin at the middle than the edge called as concave. Here, this one on both sides thin at the middle, so we call it as biconcave. Bi means on both sides. Yes. Next, look on this one. Here, one side is plain, and that another side is thin at the middle. Thin at the middle means concave. One side plain, another side thin at the middle, so it is called as plano-concave lens. Plano-concave lens. One more is here. Look on this one. See this side, how it is looking. This side it is thin at the middle. Thin at the middle, this side means it is concave. On this side it is thick at the middle, means it is convex. One side it is concave and on another side it is convex. So we call it as a concavo-convex lens. So these are based on their appearance. Based on the nature of those surface, we named those lenses like these types. But mainly lenses are only two types, convex and concave. Okay? Yes. So I said convex is converging, concave is diverging. Why we going to call them as a converging and diverging? Just I will show that one here only with a diagram later. Just now look on this title. I have written here principal focus. That principal focus we going to represent with a capital F symbol. Here you should be very careful. In the ray optics chapter, you will be using capital F and small f symbol. Capital F is for principal focus, which now we are going to discuss. One more will come. Small f called focal length. Later I will tell. I mean, be aware with representation of capital F and small f. Capital F is a principal focus and small f is the focal length. Yes, this is a very important concept here. In exam, they will be asking question on this one. Define principal focus, and even they may ask define focal length. Means you should know what they mean exactly. See here. Here I have drawn two diagrams. This side I have taken biconvex lens, and this side I have taken biconcave lens. Look here. This is biconvex lens. The geometrical midpoint of that lens is called its optical center. Geometrical midpoint called as optical center. Already I said biconvex or that biconcave lenses are made or are a part of two imaginary spheres. In previous class I was saying this biconvex lens is a part of two imaginary spheres. For this side curved surface, here you can imagine one sphere. For this curved surface, this side you can imagine one sphere. Similarly here, for this one you can imagine one sphere here. For this you can imagine one sphere here. I mean this biconvex and biconcave lenses are a part of two imaginary spheres. Now you concentrate here. Here O representing the optical center. Okay, yes, here also I have mentioned O representing optical center. Then this horizontal line, this line, and here it is there. The line which is passing through the center of curvature of both spheres and optical center is called as principal axis. In previous class I have shown that this side one sphere there one center point is there, and here one sphere there one center point is there. A line which is going to join center of curvature of those two imaginary sphere is called as principal axis. This one is principal axis. Okay. Similarly here this one also. This is principal axis. Have you understood? Yes. Now you concentrate. What mean principal focus? Look on this diagram. Here I have taken three light rays. These three light rays are coming from one distant object. Somewhere at some infinite distance, a source of light is there. From that source, these three light rays came. Right now here, how they are looking? These three light rays are looking parallel with respect to each other. Here also, these three lines are parallel with respect to each other. I mean, this is a parallel beam of incident light. Here also this is a parallel beam of incident light. What means? See here, these three parallel light rays getting incident on those lenses. Here on convex lens and here on concave lens. What happening here? Here that lens being with a two surface means here there is a double refraction phenomena is going. Here also double refraction is going. Now here I will show that how light rays here they are going to converge, how here they are going to diverge. But before that, one thing I will tell you about this. A parallel beam of light after getting refraction from lens, it is going to a parallel beam of light after getting a refraction from the lens is going to converge at one particular point or appears to diverge from one particular point on the principal axis is called as principal focus. And what it means? Just you look on the diagrams. These three incident light rays, after getting refraction from this convex lens, they got intersected at this point on the principal axis. These three, this one came like this and it bent inward. Why it bent inward later I will show here. Just look on the diagram. This light ray bent inward and this one keeps moving straight and this one bent that side. Finally these three refracted light rays got met at this point which is on principal axis. In the case of convex lens, those refracted light rays are actually or really going to meet at one particular point on the principal axis. Those refracted light rays are looking like they are going to converge, they are going to meet. That's why that convex lens we are going to call as a converging lens. I mean a light which is getting passing through convex lens, thereafter it is going to converge. That's why that lens we called as converging lens. But when we see this concave, you look here, this light ray, it came and passed through that concave lens. And how you see here, I mean how it looking? You see here that light ray bent outward. This bottom one also bent outward. These three refracted light rays are looking like they are diverging. Refracted light rays from concave lens are looking like diverging. I mean concave lens is diverging the incident beam of light. That's why that concave lens is called as which lens? Diverging lens. Convex called as converging lens. See here, why that happening we will discuss now. Firstly, now what mean principal focus? Principal focus means definition you have to write in exam. A parallel beam of light after getting refraction from lens is going to converge at one particular point. See here, this is a parallel beam. These three light together indicating one parallel beam. This parallel beam is going to converge at one point on the principal axis. Okay, a parallel beam of light after refraction going to converge at one particular point on the principal axis or appears to diverge from one particular point on the principal axis. Look here. These three light rays are looking like diverging. You take them back. You extend them back. When you extend these three divergent light rays, those three light rays obviously looking like coming from one common point. You extend it. See there. These three looking like coming from this one particular point on that principal axis. This is a divergent point. This is converging point. This point we call as a principal focus. There I have written capital F. This, I mean, if we take that incident beam from this side, then they are going to converge that side. That's why on both sides. Here one thing you concentrate. This is one side surface and this one is another side. Okay. For this is F dash. I have mentioned F and F dash. Both are principal focus only. Okay, f dash correspond to this side surface. I mean, you just look here. This is one surface and this one is another surface. For this we have to treat f dash, and for this we have to treat f. Okay. Similarly here I have mentioned what I mean finally principal focus. A parallel beam of light after getting a refraction from a lens is actually going to meet at one point on the principal axis or appears to diverge from one point on the principal axis is called as principal focus, capital F. It's a very important question, will be going to appear in exam. It's very important. Have you understood what mean principal focus? I said don't get confusion with f and f dash. Why we mean with f and f dash? Already I said lens is a part of, lens is made of two surfaces. Here we are taking biconvex and biconcave by telling two. That's why for this f dash there, for this f is there. Similarly for this one like here, for this one like here. Getting? Yes. Now see here. Why that convex lens going to converge the incident beam? Why that the concave lens is going to diverge the incident beam? Why we call them as a converging and diverging lens? Just you see what exactly happening through the lens. Here we will see how that refraction phenomena is going to take place. See, that we call as a double refraction. This one only I will take here. Look here. A very thick lens I am going to take. It's a thick lens. See, for this one, here there is imaginary sphere. That already I said, lens is a part of two imaginary spheres. And here also. This is geometrical midpoint of the lens. This portion only we can call as lens. This is optical center O. Here for this surface, here there is a center point that we call as C1. For this imaginary sphere, here there is a center of curvature which we call as C2. Geometrical midpoint of respective spheres. Now the line which is going to join them, is called as principal axis. Now you concentrate. This dotted line indicating principal axis. Somewhere you see one line here, an object there, a point object there. This is point object. From that point object, one light ray is coming. It is coming like this. See, this is a light ray. Came from that point object placed on the principal axis. Now that light ray got incident here. This is our point of incidence. Now already I said, you look here. Here, this is imagination only. There not sphere is not there. This portion only we have to take. This is only lens. That is our imagination. This lens is a part of two imaginary sphere. Mean just this side of this curved lens, which medium is there? Air medium is there. Here air is there. This is a transparent material called a lens, and this side also air medium is there. This lens is surrounded by air medium. Now this light ray from that point object is moving from rarer medium to denser medium. That lens made by a glass material. So light moving from rarer to denser. It got incident on this surface here at this point. Yes. Immediately what you have to do? You have to draw a perpendicular line to that point of incidence. I mean, you have to draw normal. How to draw that normal to that point? Firstly, you see this line. If you take that point towards that center of that respective sphere, then obviously that line, I mean, see, like this way. This we have to extend like this. See here. This is imaginary sphere. This is a point on this circumference. Obviously, this radius is being perpendicular to that point. I mean, this is normal right now, like this way. This is tangential line, okay, and that is normal. Here, this is normal. Now you look. Light ray is moving from rarer medium to denser medium. Then instead of going straight, that light ray is going to bend towards the normal. Instead of moving straight along this red dotted line, that light ray, when it enters into that lens, it bending towards the normal. This line is normal. Now you see that light ray, instead of going straight, it going to bend inward. Yes. Getting what I mean to say? So this is okay, P, and this point is Q, and right now this is R. PQ. See that PQ is an incident light ray for this side surface. Okay? Yes. It got refracted. It bent inward because it was traveling from rarer to denser. Fine. Now this QR light is incident light ray for this side refracting surface. This one. For this side it is incident light ray. Now this QR is incident to this point. Yes. Now immediately, now there to that point, you have to draw again one normal. Means what you have to do? Just you join that respective point to their respective center of curvature. The center of curvature of this curved surface is here. I mean, this is the normal. You join that point here. This is the normal. See. Yes, this is normal to this point. This is tangential. Yes. See now. See here. This is normal. This line is normal. Light ray. This QR light ray. QR. Coming from which medium? Denser medium. And it moving towards which medium? Rarer medium. Light QR moving from denser to rarer. Means it has to bend away from the normal. Instead of going, this is QR. This is QR. Instead of going straight, instead of going like this straight, it has to bend away from the normal. Look, where is normal? This is normal to this point. This is normal line. This side with respect to denser and this side with respect to rarer. I mean, normal is here. QR light instead of going straight has to bend away from the normal. That's why that light ray is still bending like this. Yes. Have you understood? This you call as yes. See, look on that path P to Q, incident light on first surface. QR refracted from that first. How it bent? It bent inward. It came along QR. Then QR got incident on second surface, moving from denser to rarer. That's why this QR bent away from the normal. Normal is here. Instead of going like this, it bent away. That's why look on this path. How it looking, that path? Is that path looking like converging? Yes, you see. Actually, the initial path of that incident light on lens is here. This is the initial path of the incident light on the lens. What that lens made here, this convex lens. See, instead of sending that like that, it deviated their path like this. I mean that biconvex lens made that light to come across, come towards the principal axis. I mean that biconvex lens allowed that light ray to intersect that principal axis. Okay, I mean here. Similarly, if you go like this, if you take one more light, see here. See what I mean to say. If you take this light, if you take this light from that point object, this light, okay, this light, yes, this light ray got incident here. How it got incident? Yes, you just join that point to that respective center of curvature. Here, this is center of curvature. Now to this point you draw a tangent. This is normal. I mean that light ray is coming along the normal. That light ray is coming along the normal. That's why already I said a light which is going to get a normal incidence will not change its path. It keeps moving without any deviation. That light is moving like this type only. Yes, that also came here. Okay, suppose if you take one light here like this, one more light, yes, it got incident here. Again, same analysis, what you did there, same you have to, yes, you join this, see here, this is normal, okay, center is here. Now this light ray is moving from rarer to denser, it has to bend towards the, see here, this is normal right now, normal. Okay, rarer to denser. Instead of moving straight, it has to bend towards the normal. That's why it's bending like this. Yes. Now it got incident now here. Again to this you have to draw one normal. The center of curvature is here. This one. Okay. Yes. Here center of curvature is here. So now this is looking like normal. This is normal. This light, okay, moving from denser to rarer. Instead of going straight, it has to bend away. I mean, this light will go like this. See, this light will come like this. It will bend like this, and it go like this. See. Look on this part. Look here. This light, it came like this, bent like here, and finally it came here. This light, it went straight like this. This light, okay? Yes. Here I have shown why it bending again that side. Because by obeying the laws of refraction, that you have to concentrate, very important. Yes, this is coming here. See that what happened in that biconvex lens? Convergence. These three refracted light ray got met here in this point. They converged. That biconvex lens made those incident light to converge somewhere. That's why that convex lens we have to call as a converging lens. Converging lens. Have we understood why we call as a convex lens as a converging lens? This is very important. You should know this. Okay, this is called as a double refraction. When we are taking a thick lens, at that time we are going to imagine like this. Okay, but in our chapter, instead of going like this with a thick lens, we will be treating it as a thin lens. Thin lens, I mean this one only. Instead of showing like that thick, we are going to show it as a thin lens like this. Here there is an object, same lens. Okay, this is Okay.